All right. Calc AB, assignment 1. This was just a review assignment of a lot of different algebra stuff. I mean, this is just to get you going. We're going to be covering some of this stuff, in the next couple of weeks. So just try your best. You should have tried them all already. Checked your answers online. And here's an opportunity to see how to do the problems you got wrong. I'm just going to go through order. I'm going to show the work. You should have work for yours also. And we'll just start getting ready. So inequality. So the way you solve inequality is you try and get it's just like solving an equation, trying to get the x variable by itself. Now, by the way, just because it's multiple choice doesn't mean you don't show your work. On the AP test, there's multiple choice questions, and often they are more work than non-multiple choice. They require you to simplify your answer in ways that you wouldn't have to for free response questions. So multiple choice is not an excuse to not show work. We only guess if we have to, and that's on the AP test. On homework, you're not going to guess. So got to get the x by itself. This is just, good work to show to not make little mistakes. Now you got to remember when you divide both sides of an inequality by negative, you have to flip the sign. So the answer is A. Number 2, one of the roots. Roots are like x-intercepts. So we'd probably try and factor this. If you had to, you could use quadratic formula, but that's a lot more work. And it works if it's not factorable. But pair of numbers that multiply together get -2. One's got to be positive, one's got to be negative, and one's got to be 1, and one's got to be 2. But we want to get a positive 3 in the middle. So I think if we put the +2 here, that gives you 4. -1 leaves you with 3. So the roots are 1/2. You set each of these equal to 0. Zero product property. And looks like that's the only one listed there. Number 3, when this is divided by that, the remainder is what? So now division, well, that's just like factoring. So we could try and factor it first. There are ways of dividing polynomials, synthetic division, long division, but that'd probably be, if you're dealing with polynomials of degree bigger than 2, then those methods might be necessary, but it's quadratic, and so it's either factorable, it's not. We're usually pretty good at factoring quadratic trinomials. So 2 numbers that multiply together positive 4, so they got to both be negative because you want to get negative in the middle. So it's either 1 and 4 or 2 and 2, and they got to add up to 7. So if we do 1 and 4, that would give you 6. If we do 2 and 2, that would also give you 6. So that's actually not going to work. So it's not factorable, but we're actually looking for the remainder. So that's what's left when you can't factor it in. So usually there's a method we call synthetic division, and we put all the coefficients of all the terms. If there's any missing terms, you put a 0. And then you put the thing that you're trying to divide out, the root, which is positive 3. You drop the first number down, you multiply it by this number, and put that number there, and then you add these, and then you repeat. And what you get at the end is the remainder. In other words, if you divide this by this, the answer is these numbers on the bottom are going to be the new coefficients. It'd be 2x minus 1 plus 1, and the remainder in general in division, even with just numbers, is still being divided by the original divisor. So the remainder is 1. Technically, it's this whole thing, but according to our options, that's the best option. Inequality is absolute value inequality. Now, probably the way you've learned to do it is generally with absolute values, you want to get rid of the absolute values, which usually means breaking it into 2 different situations where the inside is positive or the inside is negative, because there's 2 situations where this could be true. So we do x minus 3 is less than 4, and then we do x minus 3 is greater than -4. So you flip the inequality and you change the sign of the right side, and then the word in between is either and or. Now, if you think of this on number line, this is distance is less than 4. Now, distance is on either side, less than 4. And so you're going to get this in-between section, which is an and compound inequality. Like we're going to get an open dot over here going this way and an open dot over here going this way, and they have to both be true. You can't go past this or past it. That would be an or. So it's got to be and you could solve each one separately. I'll probably show you guys some new tricks for doing these later this unit, just algebra tricks. So the final answer is going to be x is less than 7 and x is greater than -1. And they got to both be true, like I said. So it's going to be -1 to 7, and they're open dots, not including, because there's nowhere equals to. Number 5, you have a polynomial inequality. And you got to be careful, because sometimes people might do this. Like they might say, okay, well, let's take the square root of both sides, plus or minus. And so they get x is greater than plus or minus 3. And that's not quite right. So I usually probably polynomial inequalities, I don't want to do that. What I'd rather do is move everything on one side, factor it. Okay. Now I'm going to show you guys some tricks later on, but I don't know, the way you've probably done it is you say, okay, well, x equals -3 and x equals +3, and then you test. Or you could think of this as like a parabola opening upwards, and those are its x-intercepts. And you say, well, the parabola is greater than 0, so it's shaded up, and so that's your answer right there. But if you were to test each of these, well, let's see, if you test these, if you plug in 4, it's true. If you plug in, say, 0, it's false. If you plug in -4, it is negative times negative is positive is true. So the answers are here. So maybe I messed up. This is where the y would go, I guess. So we actually want to shade down. And so then you get the same answer that way. But I'm going to show you guys some new ways to do that. So get a compound inequality. X is greater than 3 or x is less than 3. Number 6, the perimeter of a square is directly proportional to the length of a side. So, so the perimeter is directly proportional to the length of a side, which kind of makes sense. And its area is directly proportional to the square of the length of a side. So a lot of times you use K for constant proportionality. Now, I don't want to use the same letter twice. So I don't know what I want to use here. Maybe a different letter. L times the square of the sides. If the perimeter of the square is multiplied by 3, so if you do 3 times P, then its area is multiplied by what to get the new correct area? Might be helpful to draw a picture real quick. This is a square, equal sides, right? So by the way, perimeter is usually four sides, right? So I guess I would assume that K equals 4. And then the area, let's see. So if we do 3 times the perimeter, we get 12s. And then that means, okay, for our new, so this is a sort of like a new square. Each side is equal to the perimeter divided by 4, which is going to equal the new 12s divided by 4. So this is this new square where each side is equal to 3 of the original sides. So if we go to find the area, 3s squared, we're going to get 9s squared. And then this is the constant proportionality for the new square. So it's kind of interesting, challenging question. Number 7, the graph of the function y equals fx is shown in the figure to the right. Which of the following is true? So you have a graph. Now these are the values. The y values are the value the function gives you when you plug in a certain x, right? So this is 2 comma f of 2. This is 3 comma f3. I'm not just writing this down because I'm looking at these and it says f1 is equal to f3. It doesn't appear to be. F1 is less than f2. No. F1 is greater than f2. Yes. F1 is greater than f3. No. F2 is greater than f3. No. So we're just looking at the graph and deciding which one is higher. Now, greater than, less than, those are the y values. So I was looking at the height of the graph to make quick conclusions. Number 8, you have a function, another function. This is called composite function. So it's where you plug another function into another one. So we would want to find G2 first. And then that means we're going to plug 5 into f. So then that's going to be 3 times 5 minus 4 is 15 minus 4 is 11. So composite functions. Number 9, you have looks like some right triangles. In the figure to the right, x equals what? Now, we can't use Pythagorean theorem because we don't know the length of this. If we did, we could. But we have two. Do you guys see the two triangles? There's a little one inside of a big one. And these sides, because these angles are equal, those are, they call those corresponding angles. And this is a traversal. That means that these sides have to be parallel because these are equal. So you get parallel lines, which will cut the lines into proportional pieces. But these are similar triangles. So it's not just proportional, parallel lines, but that's the reason why. So they're going to be proportional, which means that a proportion means it's an equal fraction, like things that have the same fraction. So we can set this up a lot of different ways. You could say, now the one thing you can't do is you can't say x over 5 equals 16 over 15. It's got to be x over 5 if you're going to go that way. This side of the triangle over this side of the big triangle over that side of the big triangle. So that would be x plus 16 over 15. So you got to make sure that you are looking at the sides of the triangles if that's what you're doing it. So now we can solve this. 15x equals 5x plus 80. 10x equals 80. X equals 8. So similar triangles. Number 10, the equation of the line in the figure to the right is what? Can you guys find the equation of the line? You need two things. You need a point and a slope. So I am going to always be advocating for point slope form to get your equations usually. But this one would be pretty easy because that's the y-intercept, right? And then the slope, you could do rise over run, but we could just count. It's going down 1 over 2. And that's definitely a negative slope. Better get a negative answer. So then I usually do point slope form. Why? Well, we can go ahead and do, usually I'm going to do point slope form. Y minus 0. So this point is 0, comma 1. Or you could use this point over here, 2, comma 0. But y minus 0 equals negative 1/2 x minus, y minus 1. So if you did that, and then you could change it, I don't know. You got to look at it. None of these equations look like they're in slope-intercept form. The other way you could do it is you could do y minus 0 equals negative 1/2 x minus 2. And you'll notice that we actually get the same answer as we did on the other one when you change slope-intercept form. But we clearly need to change some things now. Maybe we move this over and we say 1/2 x plus y equals 1. Okay, I see that right there. So it must be that. Sometimes on multiple choice, as an example, you're going to have to do extra work to change your correct answer to fit their answers. That's what I mean by sometimes they're extra work. For your response, you could write it any way you want. So here's another function. What's the value? What value of x? Okay, so we're just going to plug 5 into this. Okay, that wasn't too bad. Ooh, did I make a mistake? Oh, ooh. And that's the other cruel thing about multiple choices. They like to put answers on there that are wrong based off of quick, stupid decisions. So I was like, oh, I'm going to put 5 in that. we're actually setting it equal to 5 and then trying to figure out the value of x that would cause that. And I was a little too hasty. And the answer was on there based off a mistake that would, I guess, happen to more people than just me. So it's got to be E. Number 12, which of the following could be a portion of this graph? Now, this is called rational function. You guys should have studied these in classes before. Some things that happen is division by 0 is bad. So x can't be 0. What happens is when you divide by numbers close to 0, they're really tiny. When you divide by tiny things, you get really big answers. So the graph has a vertical asymptote and it blows up. So when you put positive small x's, it blows up this way, right? When you put negative small x's, it blows up this way. And also, as you plug in really big numbers, this gets really tiny. So it goes to 0 on both sides, and that's a horizontal asymptote. So you have a horizontal asymptote, y equals 0. You have a vertical asymptote, x equals 0. And so there you go. Got A. So we're going to study a lot of different functions and make sure you're really comfortable with them. These different graphs on here, I mean, this one would be the graph if it was 1 over 1x squared, because then that would force the small numbers on both sides to be positive. This looks like a parabola. This looks like a line. This looks like an absolute value function. You guys are going to need to be really good at all these different functions, but I'm going to give you an opportunity to get good at it. So take a little back. Which of the following could be a portion of this graph? This is a sine curve. The 2 on the inside, so generally the period of sine and cosine is 2 pi. That's how long it takes to do the whole pattern. So this looks like a cosine graph, right? And a sine graph looks like a cosine graph. So if you shift a sine graph, then you might get that, but there's no shift in here. That too affects the period. So what we usually do is we divide by the number in front of the x on the inside, and that will make the period smaller. And so sine usually goes up and then down. So this is your graph. This is where people might mistakenly think that you need to double the period. So we're going to do a lot of trig. Logs, you got to know how to do logs. So one way, the way I read them is it's saying, what should I raise 2 to get 64? And one of the ways I like to think of writing it is you could put, you could even put like a little x right here. That's what you're trying to find. You say this raised to this equals this. 2 to the x equals 64. And then you can say, well, 64 is 2 to some power, right? 2 to the second is 4, third is 8, fourth is 16, fifth is 32, sixth is 64. And so if you can make the bases the same, then you can set the exponents equal to each other to solve it. This is a number between what and what. So same idea, 3 to the x equals 30, and you're trying to figure it out. Well, you could go through and say, well, 3 to the third is 27, right? And 3 to the fourth is 81. So to get 30, it's got to be between 3 and 4, right? So sometimes we're going to have to estimate values without a calculator, and just roughly, though, to get kind of at least a close idea. Here's another log equation. So properties of logs allow you to combine logs together. You look at all the answers here, which is another good strategy of multiple choice, to see what you're expected to get. So you're expected to get an answer with x's and y's in it. Now, there's a rule for combining logs together. If there's addition, you can combine them in a single log by multiplying their insides. But anything in front needs to be brought inside first. So this would be log, and that's another log rule, where you bring what's in front, multiplying inside as an exponent. Then you could combine these together by multiplying their insides. Now, and then what we're trying to do is actually find w. So this is another strategy. We want to get this log equal to a single log over here. And once you do that, kind of like up here when we got the bases the same on the exponent problem, then we can set the insides equal to each other. So W must equal x to the 1/2 times y. Now let's hope that's one of the versions of the answer they gave us. So log rules. Here, if you're trying to solve an exponential, I showed you one up there where we're like, well, let's make the bases the same, but you can't make 10 become 2 to a power. So at this point, you'd have to use logs, because logs are the inverse of exponentials. So any log, but if you look at the answers, you have log base 10. So you could do log base 10 of 2 equals log base 10 of 10 to the t. And this is asking, what do I raise 10 to get 10 to the t? Well, it's going to be t. They undo each other. So there's this answer. Now look on here, and there it is. Okay, so there we go. Number 18, we got a right triangle. Veer to the right, sine of theta is what? So sine is opposite over hypotenuse. It's a ratio of sides of right triangle. This is the opposite side across from the angle. This is the adjacent side. And the hypotenuse is always across from the right angle. So now we don't know what the opposite side is. So we got to do a little extra work. We got to do Pythagorean theorem. So I might call this y or something and say, okay, well, x squared plus y squared equals 1 squared. And all our answers are going to have x's in them. So I'm trying to get y by itself. So y squared equals 1 minus x squared, square root of both sides, plus or minus. We're going to just deal with positive sides since it's the length of the side of a triangle. So that's the y value. So opposite, and that's the opposite side. So it's the square root of 1 minus x squared over the hypotenuse. So we got some basic trig. This was probably first, SOHCAHTOA was first introduced to you. Pythagorean theorem, algebra 1. This one, find tangent of theta. Now this angle is not so much a triangle anymore, but we can create a triangle that's associated with it. We can create a right triangle here, and this angle right here is called the reference angle. Now, this is your x and your y value, so this is -3 from here to here, and this is +4 from here to here, right? The x-coordinate is the distance from the origin, and if it's negative to the left, the y-coordinate is the distance from the origin vertically. We could find the, now tangent is opposite over adjacent, right? SOHCAHTOA. Tangent's opposite over adjacent. So opposite is going to be 4 and adjacent is going to be -3. And we actually do put the negative because it's in the second quadrant and it's should give you different value than an angle that gives you the same triangle in the first quadrant. So -4/3. 19, the domain. Now domain is something you talk about beginning of algebra 1. It's all the values of x that are allowed to be plugged into the function and that actually give you some kind of y out. There are potentially problems with division by 0, square roots of negatives or even roots of negatives, natural logs of negatives, natural logs of 0. So there's some different situations where there are no answers, In this case, we have division by 0, so the bottom can't be 0. So that means that 0 is out and 1 is out. The top, the inside, has to be greater than or equal to 0. Otherwise, you're going to get imaginary results. And so x has to be greater than or equal to 2. So we have to satisfy all these things in the domain. It has to be greater than or equal to 2. Can't be 0, can't be 1. Now, this satisfies that, right? So we don't need to say these things. If we're going to say x is greater than or equal to 2, then that's it. That's good enough because that includes that it can't be 0 or 1 at the same time. So 21 is a limit, and this might be something that I don't know if you have experience with. Now, there should be a little x right here as x goes to 2. And so what you usually do is you just plug in the numbers first. it's called substitution. But a lot of times, and if you get 0 over 8, well, that's just going to be 0. So that's kind of a simple one. We're going to get into a lot of limits, and that's definitely something that you probably would study more later in pre-calculus. But I'm going to teach you how to do them from the beginning. This one right here, if you go as x goes to infinity, the top is going to get really big and the bottom is going to get really big. So it's going to be like negative infinity over infinity. But this is the dominant term on the top. The 4 really doesn't matter when you plug in millions and trillions. The -1 doesn't matter when you plug in millions and trillions. So it's really these guys, and they're kind of the same. They're the same size term, but one has a negative and one's positive. So no matter what you plug in, they're the same size. And so it's just going to equal -1. Okay. So now a way of dealing with this is you could also factor the top and bottom. This might work. No, that doesn't do anything for us. There's some different strategies we can use. But there you go. There's your answer. That's also how you get horizontal asymptotes. So next one is x goes to 3. If you plug 3 in, you get 0 over 9 minus 6 minus 3 is 0. Now, these things right here, these are called indeterminate forms, which means they don't really tell you what the answer is. This isn't necessarily 0. It could be undefined. It might just be a number. So one of the techniques that you learned in pre-calculus probably was that it might be a hole in the graph, which is kind of an interesting phenomenon. This is kind of a rational function. If you factor the top and bottom, pair of numbers that multiply to get -3, so it's going to be -3 plus 1, and these cancel out. That's actually a hole in the graph, and that means this graph actually behaves like this function, but we can't forget that x equals 3 causes division by 0, and x equals -1. So when we plug 3 in and you get 1/4, that's what the limits are going to. That's what the function is trying to go to as you approach it from both sides, but there's actually a hole in the graph. Like the graph is missing there, but the limit still exists. So the way you find it is by trying to get rid of the hole, and then you can figure out what's going on. 24, the slope of line drawn tangent to this graph at the point has a slope. So tangent lines, you have a graph and you have a line. This is something you kind of learn about in geometry, tangent lines to circles mainly there, but it could be to any curve. And this is something that you would probably only have learned at the end of pre-calculus, maybe. So don't worry about this. I'm just kind of throwing a lot of different things at you. But this is your x and your y value. We'd want to find the slope of this graph. Now, the way we find slope in calculus, and I'm just throwing this out at you, don't worry. If you're not sure about any of this stuff, don't worry. We're going to go over all of it again and again and again. This is just to get you thinking, get you warmed up. You didn't have a summer assignment, so derivative. There's something called the power rule, and we use this little symbol to represent derivatives, powers. Now, derivatives in calculus, this is definitely a calculus thing. So I'm throwing a little calculus at you. You don't need to know it yet. Not going to mean you use it on your first test or second, or, It says if you have x to a power, you multiply the current power in front and then you decrease it by 1. So this is a derivative. Now, this is a formula that gives you the slope along that curve anywhere at any x. So you plug in the x now. We call this y prime. Sneeze. So you plug that in. And you get 3 times 4 is 12, plus 4 is 16, and that would be the slope of the graph. Now, 25 is definitely a tough problem that maybe you would have only done in maybe pre-calculus. If you didn't take pre-calc or you don't remember this, that's fine. Like I said, just throwing a lot of different stuff at you. Ted can afford to buy 120 feet of fencing. So here's this fence, it's got a river. Find the dimensions of the rectangular enclosing maximum area where one side of the rectangle is a river. So we don't need to build a fence along the river. It's a natural boundary. So we got to build these fences. It's rectangular, which means opposite sides are equal. And we have 120 feet of fencing. That's the perimeter, but that's just 2 X's and a Y, right? So that's got to be something that's always true. We could just kind of guess and check. You'd be like, let's make these, you draw a little picture. Let's make these 10 and this 10, and then that means there would be 100 left here, and the area would be 1,000. Okay, well, let's see if we can do better. Let's do 20 and 20, and that would leave 80 here. And then the area would be 20 times 80 is 1,600. Okay, well, that's bigger. Yeah, you keep going. All right, well, let's make it 30 and 30 and 60. And the area would be 30 times 60 is 1,800. Even better. All right, we can keep going. We say, well, okay, let's make it 40 and 40 and 40. And the area would be 1,600. So now it's starting to go back down. So I think the biggest area is somewhere in between here, right? Now, it ends up being the greatest area, 1,800 square feet. That's just guessing and checking. In Algebra 2, we might have used an approach to be like, well, the area is going to be length times width. In my case, X times Y, if you want to use those letters. And then you could say, okay, well, let's get X or Y in terms of the other one. Let's use this restriction and say, okay, well, Y equals 120 minus 2X. So then we could say, okay, well, X is X, Y is 120 minus 2X, and then that would be 120X minus 2X squared. And then you're looking for the biggest value of this graph. What's that graph? Well, that's an upside down parabola, right? And the biggest output of that's going to be at the vertex. So then you can find the vertex. You can say, well, what's the vertex? There's this equation you probably memorized in Algebra 1 for quadratic functions, and the vertex was at negative b over 2a. Maybe just memorize that. So the b value, and this would need to be written in standard form, negative 2x squared plus 120x plus 0. So the a is what's in front of the x squared, the b is what's in front of the x, and the c is the last number. So negative b over 2 times a would be negative 120 over negative 4 would be 30. It says that x has to be 30. Well, there you go. We got it. And it's got the same answer, right? Now, after that, you can figure out what the y is. You can say, well, y was 120 minus 2 times x, which is 30. So y would have to be 60. All right, and then the area would be x times y, so it'd be 30 times 60 is 18,000 or 1,800. And this is, I'm just throwing a lot of different stuff at you. Okay, don't get worried about this. But in calculus, pre-calculus, we take an even different approach, more efficient, based off the same ideas. The idea that right here, this vertex, the slope of it is always going to be 0, slope of the tangent line. So we could do that derivative thing I was just doing there. We could find the derivative of a, and that would be 120 minus 4x, and then we could set it equals 0 because we know it's going to be flat. And then we could say, okay, well, that means 4x equals 120 and x equals 30, and you get the same answers that way, but a little quicker. So these are all things I'm going to teach you guys how to do throughout this semester. We're not even going to do all this stuff in the first unit, but just trying to get you going, get you thinking, start to challenge your mind. Some of these were obviously too hard for you guys right now, and that's fine. Don't worry about it. I'm going to teach you how to do everything. We're going to go through all the algebra skills, geometry skills that you need. And I even started sprinkling a little calculus in here, but don't worry about that if you haven't seen it yet. Okay, so hopefully you feel better about most of the questions on here. Maybe some of the ones that you've seen before but forgot how to do, or maybe you know how to do but you made some silly mistakes on. So, all right.